Hey everyone, welcome to Singularity Computers, Client Build 22, Part 7. Let's get this loop built. The loop is finished, and it's now time for the best part. I can't wait to see the discussion in the comments about this loop. It's actually one of the reasons that I built it this way, because every time I've ever done a parallel configuration, even if it was just for the GPUs, I've had so many people telling me that it's not going to work. So I've just been waiting for the opportunity to show a full loop in parallel, like this one, because well, the discussion is just going to be awesome. We're going to have people talking about fluid dynamics, and I just hope it creates a fiery discussion and debate, because I used to do, a lot of things like that in the old days, and it kind of reminds me of when I first used an acrylic tube, and it was the first time anyone commenting on that video had ever seen it, put it that way. And people really didn't like it, and the main reason they didn't like it is because back then the only hardline fitting size that was available was for 12mm tube, which only has a 10mm internal diameter, a lot smaller than what people were used to back then, because everyone was using 1/2-inch soft tube, and that's the internal diameter, so the tube is massive. And so people thought it was restrictive, and so that was the only comments I really got. And I still get those sorts of comments on those videos every now and then, and go back and answer them, and it's an old discussion that's just gone on for years and years. The coolant I'm using, as always, is Mayhem's, and I'm using X1, and these little 100ml bottles of concentrate make a whole liter of coolant, which is absolutely awesome. And I'm going to be using Mayhem's X1 clear UV blue dye, which is just an amazing dye. It works so well with dark side UV lighting. I'm switching on the pump for the first time, and you'll notice that it's only running at a fraction of its RPM. And that is because this is one of the new EK-D5 PWM pumps, which if they don't receive a PWM signal, they only run at 5, maybe 10% of their RPM. The good thing is there's a little custom cable that you can build to give a signal to the PWM so that the pump runs at full RPM when you are filling the loop. This is only while you are filling it with an external power supply like this one, which you have to do when you are filling a loop. I definitely don't recommend, connecting the pump up to your system and booting it to fill the loop. But I'll show you the little cable mod later in this video. Now, you would have noticed there that when the pump was running at a fraction of its RPM, only the GPU water blocks were receiving flow. The monoblock wasn't receiving any flow at all. So this shows the potential problem with parallel, where if the pump is not powerful enough, you're not going to get proper flow throughout the loop. But you can see that now that the pump is running at full RPM, we have good flow, and we also have flow in the monoblock. But there is an air bubble in the monoblock. This is nothing to worry about. It's something that you always see when you first fill a loop, although it is a little bit more than you would usually get, and I'll talk about that later in this video. But you can see that the flow is still very good. And the flow is amazing in the other parts of the loop, a lot higher than I normally see. And that's because a large portion of the loop is in parallel. So it's increasing the overall flow. The water cooling loop is full, and I've just completed 12 hours of leak testing. I have no doubt that a lot of you are going to be thinking about that air bubble in the monoblock. And I think for some people it's going to be damning evidence that there's not enough flow in this water cooling loop, particularly in the monoblock, because of the parallel configuration. There's definitely going to be some good discussion. For me, it's just evidence of something that we already knew. Because of the parallel configuration, the flow is being cut into thirds, and therefore, depending on the pump and the design of the rest of the water cooling loop, there is potentially going to be less flow. The real question is it enough flow to achieve the temperature results that I expect from this water cooling loop and that I want? The temperature results are definitely going to be the deciding factor. And the answer is I don't know, because how could I unless I'd built this exact configuration and done all of the testing previously? So this water cooling loop is a little bit experimental for me, and it's all part of the fun, and I cannot wait to see those temperature results. There's something that a lot of you are no doubt not going to be considering, and that is with flow, you have a huge amount of leeway where you get to a certain point and going higher makes little to no difference at all. And I think that we are within that range, but we're just going to have to wait and see. You could say that we're starting to get into territory where it's becoming more about form than function. Now, when I first started years ago, I started with overclocking. So for me, it was all about function. And the whole industry was like that too. It started all about function, and it's become more and more about form. And we've actually seen overclocking just drop in popularity over the past few years. I mean, people hardly even talk about it or do it anymore. Well, certainly not compared to how it used to be with all of the big competitions. And I just think that it's kind of faded in importance compared to aesthetics. It's certainly becoming more about form. Now, for me to do anything that's more about form than function, I don't think I would at this point at least, but I'm definitely heading more in that direction. With this water cooling loop, if those temperatures are not up to standard, I'm not just going to leave the loop as is. There's a change that I could make to essentially double the flow to the monoblock without actually changing the overall design and aesthetics of the water cooling loop. But I would prefer to leave it out unless I absolutely have to add it. But I'll certainly add it if those temperature results are not what we expect. Okay, the air bubble was gone within the first 30 minutes. So that is not throwing up any major warning signs to me. It's something I've seen many times previously, particularly in big K-Slabs builds where you have one D5 pump and multiple radiators, multiple water blocks, and a big long water cooling loop. I've seen air bubbles like that have taken a full day to come out. But there's no question that if this loop was in series, that air bubble would have been gone within the first 10 minutes. And also if this loop had a second D5 pump, it would have been gone within 10 minutes. So why did I actually build the loop this way? Well, because I wanted to do something a little bit unique and different, something really clean, something that suits this case. And actually, I'll explain the original idea I had. And I couldn't go ahead with this because, well, it's not something the customer really wanted. I was going to take off from here, straight back into the back section of the case. And then I was going to come out right there, right next to the fitting and connect straight in. So that tube would have been mostly invisible. But let me explain what actually pushed me in the direction of parallel with this build to begin with. It's the fact that there's only a single opening in the top of this reservoir, which is very restrictive. Normally, for the tubing routing, I would have gone from here, through the components and around. Then the coolant would have come obviously back down to the bottom of the build, exactly where I need it, because then I can go to the radiator and back to the components. It just would have been perfect. But because there's only a single opening, that has to be the fill port. I cannot connect to the top of this reservoir, meaning that I would have to go from here all the way around here. And a long length of tube like that is something that you will never see me do, because it shows the builder has not thought out that loop properly. The most important part of a loop and the basis of a loop is the component order. There is always a component order to give you a short tubing routing. And what you need to do, as I always say, is take the component order that is going to give you the shortest possible amount of tubing. You want the least amount of tubing possible if you're going for a clean, high-performance loop. But there is something else I could have done. I could have just gone straight from here up to the monoblock, and then come back through. Either way, the loop would have looked quite similar. The only real difference would have been that one of these tubes here would have actually been at the top. But, I wanted to do this because it's unique. I want to experiment with it and test it. Okay, if you ever run into this problem that I've talked about with the D5 pump, and I have talked about this previously, this is how you can get around it. What we're doing here is we're just running a signal to the PWM, and the pump will then run at 100%. So you make up a little custom cable. I've just used 18 gauge wire. This is a 4-pin PWM connector, and you can see the pin out that I have run here. On the other end I have a Molex male pin. The Molex male pin needs to be plugged in to the pump power to the 5 volt, which is on the end here. So that goes in there. The other end goes into the pump PWM cable. And that's not what this is, but you get the idea. And when you plug the power in, obviously the 5 volt gives 5 volts to the PWM, and it works perfectly. I've installed all of the custom wiring, and I'm now working on the cable management around the back of the build. And it's going to be incredibly clean. This is actually as clean as I have ever seen it, because all we have is a peripheral cable powering the pump, and also all of the fans via a Mod My Toys fan splitter. Then of course we have the front panel connectivity, and you can see that I've reinstalled it. So that's probably going to be the messiest part of the build, the front panel connections, because there is a giant bundle of cables there. But of course I'll find the cleanest possible way of dealing with all of that. In the middle we have the 24-pin and all of the PCIe, of which there is 4 8-pin. So that's basically all in one big bundle, and the wall mounting system for the Core P5 is perfect for holding the cables in position. I don't think I'm going to need to do any cable management for these at all. I've used plenty of cable combs, so they're helping to hold everything nicely, but it's just worked out perfectly. You can see the 4 8-pin is sitting on top of each other nicely. I haven't quite finished that yet though, it still needs to be cleaned up. And then over here in the corner, I have the 8-pin EPS and the 4-pin ATX. And that is all of the cables. There's only going to be 1 or maybe 2 more little 3-pin fan cables for the lighting. The PCIe cables are now installed, which means, as I've mentioned, all of the custom wiring is done. Now, originally what I had planned for the PCIe cables was to run them vertically. And I was going to run them straight down and into that cable routing hole back there, but there was nowhere near enough room to route them underneath the graphics card. The only other option would have been to run them vertically, visibly, and not run them out the back of the build, just straight down to the power supply, but I think that would have looked terrible in this build. So all I was left with was to route them around this side. And I can't even do it in a uniform way because the cable routing holes for this case are all in the wrong positions. You can see for the 24-pin it's in the wrong position, the PCIe, even across the bottom, they are really badly positioned. And across the top, because you can see for the 8-pin EPS and 4-pin ATX, they have to go diagonally as well. So it's something that was, really not thought out very well for this case. I'm sure for one motherboard it might fit, but for the rest, the compatibility is not very good. Whereas normally for most cases I don't often run into these problems. So that's actually a mod for this build that I really would like to have done. Probably put a panel over the entire motherboard area or shrouds all the way around and cut new cable routing holes. But I'm pretty happy with the way the cable routing has turned out, considering. And the fact that the 24-pin curves down like that, I don't mind so much that the PCIe do as well. And looking from the front, they are uniform. And I actually quite like that routing. It's a routing that I like to do, either going outwards or inwards. It looks nice. So that's it for the custom wiring. And at this point, the build is really minutes from being ready to boot. I just need to install the lighting. Now, normally that would take minutes, but in this case, where am I going to install it? Now, on the inside of the glass is an obvious answer, but I don't have the glass with me. So what I would actually do for this build is put a little rim around the outside of the glass and install the lighting there. And I'd install one LED strip, dark side UV LED strip on each side. And that would just look amazing. But I don't have the glass and I'm not going to be able to get it. So what I'm going to do, I'm going to install a little shroud up this side of the radiator and install probably a couple of LED strips facing different directions on the inside of it. But that's not going to give me lighting across to the main part of the build here. So the lighting is a difficult one. See if you can think of anything for me. Okay, let's go through the fittings I've used in this build, because it's something I always get asked about many, many times. So underneath here for the drainage system, I have a 90-degree single rotary, a male-to-male fitting, and a mini valve. And I also have a stop fitting on the end. So that's a great position for the drainage system. It's at the lowest point. It's easy to install, tubing onto it. Just a perfect position for it. So let's start from the outlet on the pump. 90-degree dual rotary, 16mm hardline compression fitting, 90-degree single rotary, 90-degree dual rotary, 90-degree single, 90-degree single, 90-degree dual, 90-degree dual. Now down here, I had to put a little extension. So that is just a 5mm extension. Now normally I would never do that, but I only had 500mm lengths of tube in stock. And that is a 500mm length of tube. So it almost reached, but not quite. So then I have a 90-degree dual, 15mm extension, 5mm extension, 35mm extension, and I did that so that I can get 45mm, and there's no 45mm extension as far as I know. 90-degree dual and 90-degree dual. Okay, I'm going to have to leave this part of the build log here. In the final part of the build log, I'll install the lighting, which is going to require a mod. We'll then move on to a good look around the finished product, and then finally onto the test results, and I can't wait to find out how this parallel configuration is actually going to perform. Singularity Computers products are now selling at performance PCs in the USA, which is a huge milestone for Singularity Computers and for the channel. Our products are now selling internationally. We are also selling at DOSMode, HighFlow, IceMods, and E22. All profits from our parts go towards improving the channel. Thanks for watching, and remember that none of this would be possible without our patrons.